All right, well, let's get started then. Just so everybody's aware, we are recording. So if you don't want to be seen on a public video, or perhaps might want to say something super spicy during the next hour and 30 minutes, just reminded that it is going to be published eventually. Sidebar, I am working internally still on that handoff. I have access to most ECC socials, but I do not have access to the YouTube right now. So working on getting that sorted out over the next couple of days. And then I think after that, we've done everything we needed to from a operations standpoint. So ECC is hosting this Arborist call, and welcome everybody. Today's January 26, 2023. This Arborist call is being hosted in the 22:30 UTC time slot. So late for some people on here, and then earlier for others, but obviously we're doing two different time slots to make it work for all the different time zones that we are working across. So the agenda for today is we're obviously doing the welcome and the meeting intro right now. We're going to be going over to Zebra updates. Then we'll move to ECC core updates. After we do that, we'll have a quick presentation from, correct me if I'm pronouncing this wrong, Wolfram on their blockchain, okay, on their blockchain integration API, potentially including Zcash support or adding Zcash support. Am I saying that technically correct?
Yeah.
Okay, cool, awesome. And then we'll dive into research and implementation status updates, where we'll cover a number of different research items that all the organizations building on Zcash are working on. We'll move to open discussions, but we have a pretty free-flowing discussion during all of this. So if there's any lingering discussion items that we need to cover before we wrap up and answer any comments from the audience, we do that during like the last 10, 15, 20, 30 minutes, depending on how discussion goes. So what are the Arborist calls? They are bi-weekly calls where Zcash protocol contributors, we get together and discuss different upgrade timelines, process, protocol R&D efforts, design and implementation of new protocol features, and we also collaborate to identify blockers and any unresolved issues with the items that I've just mentioned. And the purpose is to make Zcash core protocol development accessible to a wider set of participants and provide more transparency to the community at large. Anybody can join and participate in these conversations. And who can participate? Anybody. So anybody who's interested in learning about Zcash protocol development at large can register. If you want to present an in-depth agenda item, you can reach out to me at isagsetter@electriccoin.co, or you can message me in the Zcash Arborist call section of the Zcash R&D Discord to request a presentation slot. And other ways to get involved in Zcash is via the Zcash Community Grants Program. There's a number of different RFPs ranging from non-technical items such as education and podcasts to more technical protocol development. If you want to look at the different things that they're looking to fund right now, you can head to their website. There's also a grants program between Filecoin and ECC that is looking to do a number of different things between that would technically benefit the Filecoin and Zcash ecosystems. Those grants are paid out in FIL tokens. You can apply and learn more information about the grants there. And then if you just want to discuss broader Zcash development items, you can head to the Zcash R&D Discord, where people convene to just chat about protocol development. So the first item that we have here, I'm going to pass it over to the Zcash Foundation to provide some updates on Zebra.
Just while I'm speaking, Dara would like to be promoted to a panelist.
Yeah, just checking my chat now.
I'm Tiora, I use they, them pronouns, and I'm the current Zebra team lead at the foundation. So Zebra, recently we've been focusing on support for mining pools. So in the last few weeks, we've implemented different mining RPCs like get peer info, get block subsidy, and the get block template proposal mode. We've been doing a lot of RPC testing and fixing a bunch of different bugs. So for example, fixing the order of the transactions in the Merkle route, making sure we don't choose the same transaction twice in the block template, and fixing up the times in the block template. And we've made a bunch of changes to make Zebra's output format as similar as possible to Zcashd. Even though it doesn't matter in JSON, it's just a lot easier for us to do testing if all the fields are in the same order and all the transactions are in the same order. One of the other changes we made in our production code was that we added a transaction lock time check to the mempool. This was something we missed when we originally did the mempool. It's actually not specified anywhere. So we had to go to the Zcashd source code to find that. And credit to DecaSU on GitHub for reporting that bug to us. We've made some internal changes, but they're kind of boring and only really for Zebra developers to notice. So probably the biggest internal change is removing some duplicated Red Palace code. So we don't have two copies of that code, one in the Red Palace crate and one in Zebra itself. So that's about it from me. Are there any questions?
The duplicated Red Palace logic. So that was, you were deduplicating with the Red Palace crate specifically?
Yeah, so Zebra had a copy of Red Palace as a module, and it also, and the code was almost identical.
Cool. So we're just... Excellent, because we also have the Red DSA crate, which we need to reconcile at some point. I wasn't sure if it was that one you were referring to.
No, it's just Red Palace for the moment. I think Red DSA is not a question for me. It's probably a question for Deirdre or Conrado.
Yeah, I think the original plan when we did the split was that we would bring them back together into, well, originally Red Palace repo, but we'll see how, I guess, things go. Particularly now, I guess, that Frost has made a lot more progress in implementation. We can figure out what we want to do here offline. Because I think currently that means we have 4 different implementations of Red Jub/Palace, maybe 5.
I mean, we're almost about to remove one, so that's one down. But yeah, definitely agree that we should have one copy and get it audited, and then we know it's correct.
Hey, awesome. Conrado, I see that you have your hand.
Yeah, just say with the duplicated code, and we're now using the Red DSA crate. So I think there isn't a Red Palace crate. So yeah, we actually there's now one less copy of the code.
Okay, that's good to know. I think at some point we can discuss offline how we make progress forward on that, but we'll make sure to keep coordinated on that, because it'd be good to centralize around that crate as the thing to use.
Awesome. Dara?
And can you file an issue on Zcash SIPs about the documentation of lock time?
Yeah, sure. I'll link to our ticket because I think that's probably the best explanation, but I'll file that issue there.
Okay, thank you.
Awesome. Brilliant. Any more questions on Zebra? See Deirdre. Deirdre, go ahead. Sorry.
One other motivator besides deduplicating is I think that Red Palace implementation had a early implementation of Frost because it was forked and rejiggered off of the implementation of Red Jub, which had Frost in it. That was one of our first implementations. And the old implementation of Frost on Red Jub is basically deprecated, and it's getting cleaned up by Conrado. And so the Red Palace implementation that we deduped, now we've gotten rid of that old implementation of Frost. And so the Red Palace crate will include the updated with the spec version of Frost, implementation of Frost as well. So yet another reason to remove old duplicate code.
Yeah, there was a question on one of the Telegram groups, I think either ZK Study Club or ZK Podcast, about where to find the a Frost implementation. So I was having to direct them away from some of the duplicates.
Yeah, we have the primary like Zcash Foundation /Frost repo. We have a lot of stuff going in there, including the re-randomized variant of Frost that is intended for applications like Zcash signing. But then that can be consumed by Red DSA. It can be consumed in several places. But basically Zcash Foundation /Frost is where most of our Frost development is happening up to date with the specification.
Oh, I directed them to the right one.
Oops.
Awesome. Thanks to the ZF team for the update there. Gonna reshare screen here and we can move on to the ECC core updates. So gonna move over to the next screen so we can go over the ECC core updates, and yeah, anyone from the ECC team wants to take that away.
I'm not sure if this got updated since last time. I see. Yeah, I think this might be the same slide as last time.
Okay.
We didn't update, so you just go back to the previous slide then, out of the way.
Yeah, no worries.
So the last 2 weeks we've basically been on the Zcashd side focusing on getting a 5.4.0 release out. This RC series has been more exciting than previous ones, which is good. It makes me feel confident in the rest of the stuff we wrote when we actually find bugs. So we've found and squashed some bugs in the stuff we were deploying. We have just identified some rather serious performance regressions that we introduced while implementing performance improvements a few releases ago for the chain sync stuff. So we're just testing those out at the moment, and it'll be the next RC3 that we're about to cut in the next day or so. Aiming to get that out, the 5.4.0 release out early next week. And the other thing that this is going to include is I think Ox Arbitrage originally wrote started a PR to work on a few years ago to work on tallying up the transparent pool. So we already have in Zcashd monitoring of the sizes of the shielded pools. We added sprout and sapling before sapling launched. We added orchard before orchard launched. So we're adding transparent and also a tracker for the chain supply, defined as essentially the outputs created by Coinbase transactions minus unclaimed fees. So the logic of that being, if you look at the way a transparent transaction works, fees are defined as an imbalance between the funds consumed and the funds produced from the transaction. So if a transaction doesn't produce outputs corresponding to all of the inputs that they consumed, the delta left over essentially disappears from the supply, unless the miner claims that in a Coinbase transaction. And so what we are now doing is essentially tallying those up as we go. And fortunately, that is precisely equal to the sum of all of the value sitting in UTXOs or notes in the various value pools, which is exactly the check that we wanted to ensure we had. I think all up, correct me if I'm wrong, Chris, we end up with, there's a delta between the theoretical maximum supply and the current maximum supply of about 350 ZEC or so.
Yep, that's about right. There are about 30,000 instances of miners failing to claim fees, but they're small amounts, they're fee amounts, and so it adds up to 365 ZEC or something of that sort.
Yeah, but that's the ballpark that we expected. I knew when I did a tally a few years ago, I think I remember about 150, 160 being the number I remember seeing informally. So it's the ballpark we expect, and all of the instances, like we spot checked, we checked manually a bunch of the early ones and we spot checked some later ones, and they all seem to follow that same pattern of either, I think there was an instance in slow start where a miner was miscalculating the miner portion of slow start and was just claiming the miner reward at a lower amount. And then there was another fun instance where a miner, a Coinbase transaction was paid out to 3 different Coinbases, and because dividing a number into 3 leaves a rounding error, there was 1 Satoshi left unclaimed.
Yep. So Adi just asked, can these ZEC be reclaimed, recirculated in some fashion? And the answer to that is, it might. I think that at ZCon 3, Nathan from ECC introduced the idea of the Zcash posterity fund. And the way that the posterity fund would work is essentially exactly the same way that that this unclaimed balance works. Is that so? If in the future the Zcash community decides to implement something like the posterity fund as a sort of perpetual source of block rewards, then it seems likely that those unclaimed fees would probably be the first seed in that fund.
Yeah, because from Nathan's talk, it was essentially the delta between the circulating supply and the theoretical supply was essentially what his talk defined as that posterity fund, and that happens to also coincide with the unclaimed amounts. So
if anyone wants to check it, it's 368.5844552 Zach.
Yeah, and we also include a Python script in there that can be used to check that. So you can see that in the release branch, and one of the inputs to that is a file that contains the block height and the unclaimed amount for every one of those 30,000 unclaimed fee amounts. So, and associated with the miner address that failed to claim them.
Yeah.
Awesome. Excuse me, sorry. Taylor, you have a question?
Yeah, so I was interested in the details of how you're tracking those unclaimed amounts, because I know in Zebra we keep a total of all of the different shielded and the transparent pools. But we don't actually sum those up to the theoretical outlay or compare them at all. So I was wondering about the implementation details there. I also wanted to mention that sometimes if a miner has already done a bunch of work on or a mining pool has already done a bunch of work on a particular template, I wonder if it's more economic for them to just continue to do that and try and fiddle transactions around, or is there no way that actually would pay off?
My assumption is that's the explanation for some of these.
It's a little more in depth than that, because the moment you add transactions to a block, you have to alter the header. So there is like an update has to occur. My guess as to what's happening though is that they only are updating the header and they're not updating the Coinbase transaction. And so all at pre-NU5, all that required doing was updating the root of the Merkle tree of transactions. Post NU5, we have several other block commitments that also would need to be updated if you did this. As far as the implementation goes, we aren't tracking the deltas in Zcashd. That is a separate script that essentially compares what Zcashd is tracking to the maximum theoretical supply at each height. What Zcashd is tracking is what we are adding are two tracks. The first thing we're tracking is in every block, the sum of all outputs created, transparent outputs created, minus the sum of all transparent coins consumed. Effectively the equivalent of negative value balance. Which is what we currently track for the shielded pools. The value of a shielded pool is, because of value balance, is defined as spends minus outputs. So the delta on a pool's balance is the negative of that. So we're just tracking this equivalent same thing for transparent, which gives us the transparent pool balance. And then we are also tracking separately for each block, whatever is calculated as the fee for each transaction is counted as a subtraction on the chain supply. And then every output in the Coinbase transaction is counted as an addition to the chain supply. And so if all fees are claimed, then the subtractions cancel out with the fee component of the additions, and all that's left in each block is a delta increase on the chain supply due to the block subsidy.
And we plan at some point to add a check to ZIP 209, which is currently the consensus rule that stops shielded pools going negative, to make that consistency check a consensus rule.
Yeah, so the consistency check of both. We may as well check that the transparent pool doesn't go negative as well, because it wouldn't make sense for it to do.
Yes, that's true.
And also to check that the calculation of the chain supply and the calculation of chain supply of that method should be equal to the sum of the value in each of the pools.
Yeah, so that's what Zebra currently does as a consequence of using the same value type for all four pools, is that we're also checking that transparent doesn't go negative because our type doesn't allow negative values, yep. Which is implied by the other rules, but not explicit.
Cool. Yep. So I think that's everything on the Zcashd side. Yeah, just we're targeting hopefully early next week for 5.4.0. There's the other thing that it includes is a change to get block template that I think we might have discussed in a previous Arborist call, but essentially to move a bunch of the work that was being done on each get block template call into the mempool as a result of backporting some changes from upstream Bitcoin Core. That's been done, and it definitely reduces the amount of time spent inside create new block. There was still like about half of the time spent in create new block was spent inside checking that the resulting block was valid, test block validity in Zcashd's case. That is still there, and it's actually slightly slower because some of the caches aren't primed properly internally. That was visible, observed upstream as well. But something we noticed while doing that was that a lot of the time in a get block template call is spent outside of create new block. Possibly in the case of like these larger ones, just serializing like over 4 megabytes of JSON across the RPC. So it might be of interest to miners to consider helping out with a alternative, like maybe a binary-based API if they wanted to reduce latency there, because it does seem a lot of the latency is outside of the actual block template creation.
Is there anything in upstream Bitcoin?
I don't believe so. I mean, theirs is also bounded because they raised their soft limit to effectively 4 megabytes, so they probably have a similar problem. 8 megabytes of JSON in the limit. I haven't looked specifically to see if they've made any other improvements there to allow like an alternative way of representing the thing besides JSON RPC. But it'd be worth looking into. And then on the other fronts, we're continuing to make progress on towards DagSync. The first thing we're heading towards there is sort of like a pre-DagSync point where we can essentially decouple the making existing notes spendable from finding new notes. I think we've gotten in place basically all of the refactoring and tech debt and thing changes that we needed to do. In fact, the mining pool thing I just described was, oh no, sorry, that's at 3.17. We've done other changes necessary for that. So I think basically once we've got 5.4.0 out, the next thing we're working on is basically chasing down all the various issues and implementation things we need to get to that point. Stuff like getting the necessary commitment tree information into Zcashd, available over an RPC that Light Wallet D can consume and then give out to Light clients. Actually integrating the incremental Merkle tree changes that are currently in review, the shard tree stuff, as I think the quote will be called. Get those merged and available, and then start using them in the SQLite clients that we use underneath the mobile SDKs, and then break apart the current scan cache blocks logic to be able to separately update existing notes from finding new notes. So that's essentially our next chunk of work that we're working on.
Okay, awesome. Thank you, Strad. Does anyone from the panelists have any questions on that? Okay, great. We can move forward then. Sorry, muted myself. We will be going to Wolfram's blockchain integration service. So I'm going to stop my screen share and then pass it over to John, John Woodard. So John, you can go ahead and take it away.
So first I had to meet myself. Thanks everyone for inviting us to just kind of introduce ourselves and give you a little bit of an overview of what we've been working on in the blockchain community. So I'm John Woodard. I'm help to run Wolfram Blockchain Labs. We are actually a subsidiary of Wolfram Research. Probably the core thing that people have heard of is either Mathematica as a product that's out there, or Wolfram Alpha. We've been around now for, it's coming on like 35 years as far as Wolfram Research, which is an awful long time. I've actually worked at Wolfram Research or Wolfram Blockchain Labs for over, well, almost 12 years. So I've had an opportunity to see a lot of stuff develop. So what we're in general doing at Wolfram Blockchain Labs is extending computational intelligence into Web3 ecosystems. Computational intelligence is something that we work on at Wolfram Research, which is our parent company, all across the board in a lot of different ways. Wolfram Alpha is the biggest example of that. And what we've done in the past 5 years that we've been in Web3 or blockchain or crypto or whatever folks want to call it, is basically develop that and integrate blockchains that are out there. What we've done with that is actually a larger service, our blockchain integration service, where we actually host nodes in our own co-location center, as opposed to on cloud services. We actually built our own co-location center. Well, we didn't build it, but we rented our own co-location center as a result of building Wolfram Alpha back in like 2008, 2009, when we were deploying it. There weren't a lot of services to use. So we actually have struggled with hardware initially, but when it comes to our blockchain integration service, we actually host nodes, integrate those into our own platform, and then connect those to Wolfram language. And what we've done during the course of maybe the last few months is looking at actually creating a blockchain framework. And this is, why I'm here talking to you guys, just introducing ourselves. So it makes it easier for communities to actually integrate blockchains into Wolfram language. So that's actually one of the things that we're working on now. At present, it's just going to be for read access. I'll show you a few examples of what it's like, but it's almost like you can think of a programmatically accessible, universal blockchain explorer. And kind of beyond that, you can actually write transactions pretty easily as well. So some quick kind of examples just with Bitcoin. One, let me see if I can drop both examples in the chat. And then also our documentation, which people may find interesting to just explore and play around with. Basically, you can do all the kind of interaction you could on a blockchain explorer, except it's through our Wolfram language functions. The functions are kind of modeled after our super functions, so you can just actually change, say, changing the blockchain base from Bitcoin to Ethereum and easily running the same function and getting data. So what we want to explore and do with Zcash is in our blockchain framework, which again will be a kind of construction notebook, is what we're imagining. So notebook interface like this, where someone is able to put in snippets of code to connect an RPC API from like Git block service, connect it to functions that will be really similar to this, and it will be very, very easy to do. And then actually save that code to a code repository that then people can download and use. That's basically the structure of our system. We've actually played around with it, so we're very confident that it will work. And we've done the construction notebooks and code repositories for other Wolfram language functions and Wolfram language packlets of both code and data. So we're pretty excited. We think it's all going to work. And what we're doing is creating it as a proposal for Cardano, their Catalyst program. So it's a community-led program. So basically what we're interested in and what we've talked about with folks at Zcash is just engaging kind of the Zcash community when we put this up for a proposal on Cardano, which is supporting UTX-oriented chains to try to do cross-chain sort of stuff and cross-chain analysis of data and other things. So that's basically what we're up to. That's why we wanted to introduce ourselves and just talk to folks. And if folks are kind of interested in either using it or learning more about what we're doing, getting in contact with us. So I'm going to go back to see if this is my contact information. And then if there are any questions, I'm happy to answer them here or shoot me an email or connect with me on LinkedIn or anything else, any other service I'm on. And
awesome. Thank you so much. I see that Addie has a question.
Yeah, this is just so cool to learn that Wolfram is integrating with Zcash. One of the things that I loved about the Wolfram search was the ability to search certain data sets and view them in a graphical way. So maybe in the future, if we can find a way to create graphs for Zcash data, like how many transactions are going on in the shielded pool, the growth of different type of transactions and such. Is it something that is possible to link the search with this data set?
So in terms of connections to Wolfram Alpha, that's actually something that we're working on. But that's going to be with the larger service, just because we have we're actually hosting the nodes, and it's a bit easier. I mean, there's some things where we actually need to store the data in databases to have the performance that we need for those sorts of queries on Wolfram Alpha. That's just kind of the trade-off there. But when it comes to this, there are a bunch of examples here that kind of show what's possible with the blockchain type of functions that I showed. And you can use all the functionality of Wolfram language on the data. And there's a lot that can be done there. Most of the visualizations and things that you see within Wolfram Alpha are actually just from Wolfram language. There's a nice bridge as well from Wolfram Alpha to Wolfram language called the Wolfram Alpha Notebook Edition. And that's getting better and better all the time. And what that allows you to do essentially is start in natural language and then move from natural language to Wolfram language code in like a notebook format. So that's probably where you would want to go with things. So it may not be that we support Zcash in that way, but you could do a query like eventually, because we're very close to supporting those queries for the languages that we've done full integrations on. So like you could do it with Bitcoin and then get the Wolfram language, like do it in English, get the Wolfram language code, and then use that code to play around with the Zcash implementation, which would be in the blockchain framework. So that's kind of what I would suggest there. Going even further, which is a little bit dangerous, but I'm going to bring it up because I think it's so cool. I'm sure like a lot of people, we've been playing around with Chat GPT-3. So I'd encourage you, if you're interested in like power of Wolfram language and like exploring it and like natural language and other stuff, here's a pretty good article, because we're playing around with that stuff now, which would also give you another way of like playing around with Wolfram language kind of in a better way than not. Well, I should be careful because I'm being recorded. Someone would bring it up and see this, Stephen, but an alternative way of accessing, Wolfram language through natural language to play around with things. So that's kind of the idea there.
Yeah, that's excellent. I mean, if someone could use your feature set to track even information, people would learn about having privacy online and with their blockchain transactions. So that's one use case. And I just want to add about the grant program. You mentioned the Cardano Catalyst. I know that they have quite a bit of delay there. Like they have one program every 6 months. So maybe you could consider even applying for a Zcash grant. There's a rolling application for grants in the Zcash ecosystem.
Yeah, we're definitely like thinking about that as far as like moving up from like this initial kind of implementation to something more like, so the way we've done it now is, for a long time we did the blockchain integration, which is much more involved because we're running nodes. It's like the hardware, all the other stuff that we have to do. But in having this blockchain framework, it gives a smaller initial step, and then we can look at that kind of larger step. So we absolutely have that on our mind as something that we want to do. That's also why we wanted to introduce ourselves. But it's one of those things where it's better to kind of interact and I think show like different value and do stuff with folks, and then come back later on for maybe a grant proposal.
Okay, awesome. Strat, I see that you have your hand up as well.
Yep. So really interesting stuff here. Couple of questions from the technical side, because I know, like I say, you're providing access to the kind of data that you could also get through a block explorer. I know in the past that block explorer strategies themselves have differed wildly in terms of how they store and where they store data and things. How much are you relying on the backend node for data providing versus extracting data from it and then post-processing and things yourselves in your own data structures and things? I ask this partly as a maintainer of the full node that you're probably using, in terms of like the APIs you're using and what kinds of things this new and exciting use case is requiring for its support.
Yeah, sure. So one, I would say, this is my naive view because I am not a developer. I'm like but I am a biomedical engineer by training. So I do get to say I'm an engineer. It's just doesn't, like, the code that I can create is totally spaghetti and probably not useful for anyone, let alone myself, past like whatever initial use case. So one, when it comes to our blockchain integration, we actually access ledgers directly for all the different ledgers that we support. So, as you guys know already, there are pros and cons with that. People are able to access directly, but it's going to be much slower. We have support databases for ledgers that require it. So if you're accessing, smart contracts that define tokens, or, there are names or tickers or other stuff that are associated with tokens, then we do have support databases for that. And we're actually growing that. So we'll, in the future, it's likely what we'll have are database analytics where we've reformed and reshaped everything. And then we'll have ledger access. And we'll probably support that, in parallel. In terms of the data, we kind of have this concept of raw requests and cooked requests. So we do reshape the data a little bit, but every time we're accessing the data, we're actually accessing the ledger.
Cool. So yeah, so in this case, we can think of it as, yeah, you're accessing the data that Zcashd in this case is storing and collecting internally.
Yep.
Cool. I'm guessing you're probably using the Insight Explorer stuff that we merged to again help with one of the block explorers that we were using there. And then I guess the other so yeah, you linked some documentation there for things. Is that the best resource for looking at like examples? Because like the thing I can see as the best, as like a good use case for this is like when I've tried to do data analytics on the chain before, usually it's I write a Python script, it includes a JSON RPC parser, into a library, and I just point it at my local Zcashd and have it query the entire chain and do things that way. So it sounds like it would be about the same speed as far as what you're doing for now, but that the benefit here would be that you can then take this Wolfram language, this common language, and then you repurpose things across multiple as a common access point to multiple chains potentially, and likewise for the stuff we're doing.
Exactly. So you can access all the chains that we support in that common way, and then let me see. We also have things like the client library, the Wolfram language client library for Python. So it means that once we support it in Wolfram language, you can access this stuff in Python. You can access it in, I think we support now, so Python with the client library, Node.js with the client library, Julia, I think as well. So again, like they're like, it's not only that you have this in Wolfram language, you automatically have like, again, well-formed like this universal function kind of structure with these other languages that we support. And then also within our Wolfram notebooks, you can use, say, Python if you want to. We support external evaluation of like Python and Julia, and I think Node.js, and maybe some other languages. I don't quite know yet. So
cool.
There is a lot of functionality there as well.
Nice. And then I think the final question I have is, so as far as the per chain stuff goes, like obviously where the Zcash chain was started as a code fork of Bitcoin, so there's a fair few of the same RPCs and things, and same concepts as far as the transparent side goes. But we do have a fair bit of like other things that we can expose related to our shielded support. How does that sort of like make its way into the Wolfram language?
That's where it's going to be harder, and we'll have to figure out those will be the changes, because like when you start to look at the functions that we have, we strive to make them as universal as possible. So that's why it's like, well, it's kind of programmatically, we've struggled with how to say it in a way that people can associate it like with the functionality that you have with the block explorer, but then also see that it's more useful in ways. Yeah. So with each chain, we try to support as many of the unique functions as possible. What really helps us there is like, if you have information that highlights like in this case, the clear differences from Bitcoin as a base, that's like the fastest way our engineers can have a better understanding of Zcash to then support as many of those that would make sense and that we would have good like responses for. And then the other thing is that we do, in some cases, look at like interesting and novel ways as well to use things, because, one of the things that we're trying to do over time is make things even more accessible to folks who are doing like different data science and other stuff, where they don't have to have a in-depth understanding of ledgers to then take data from ledgers and do interesting, cool stuff with it. So we're trying to work on that. And so with that in mind, like we do a lot of our own educational stuff. So we have some study groups out there, and we're expanding that stuff, and we'll continue to do that. So that's the other way that it's really useful, if you have, again, the stuff that's unique from Bitcoin and can just kind of, here's a list of the stuff, and like or here's the best source to understand and go through that, the sooner and the better we can do a good job with that stuff.
Yeah, that sounds good.
Yeah, sorry, carry on.
Yeah, I just the thing I'm likening this to is I think the only other thing I've seen similar to this is I think there was a Google BigQuery set up at some point for querying Zcash data, and I know that I recall like looking at some of the data and squinting and going, this isn't quite right. Like the interpretation they're taking of the stuff in the RPCs is just like, So definitely would prefer to head that off in this case to make sure that that both you're getting the interesting data and also the data that you're then exposing is the same interpretation as the source. So
I'm looking at the APIs for sort of various blockchains. And it looks like it goes into some details. So for example, it passes so outputs and inputs down to the level of typed public keys and signatures. So that's interesting. I didn't really expect that. It identifies what curves they're on and so on.
Yeah, I think we've done like I mean, most people are pretty impressed with like the implementations that we have. With that said, like this is kind of a new area with the blockchain framework. And we're hoping to get that support from Cardano so we can do it with their Catalyst program. And it should be, again, like a way to get more initially UTXO chains supported, even if it's supported, like in this case, at the read level. Like if you look through the documentation, you'll see that we support writing transactions as well. And we're supporting like writing smart contracts as well with payloads from the different functions. We support that for, I know at least Ethereum, we're working on it for Cardano as Cardano has added smart contracts in. So that's pretty, it's interesting and cool as well. And there's a lot of examples in the documentation to go through and test and explore.
Cool.
Great, thank you.
Awesome, thank you so much, John. And if you're a panelist right now, excuse me, if you're a panelist right now in the chat, you can see the link to John's LinkedIn. Dara put that there. Thank you so much. And yeah, you can connect with him on LinkedIn, or you can obviously send him an email if you were able to grab that as well. And I believe Squirrel will have that in the Zcash Arborist call notes. I would have. Oh, emails in the chat. Thank you so much, John. Cool. So we can move forward here. Let me just share the next aspect, and we will move on to research and implementation status updates. So I don't know if ZF wants to go first with Zebra. Yep, Deirdre, so you put your hands up.
We can give a quick update on Frost. We've cut a new version 12 of the specification. Yes, and we are now doing what we think is the final boss stance of asking an increasingly higher number of chairs within the I*TF to make sure that this doesn't conflict with other things and approve it and blah, blah, blah. And if we do the invocation in the correct order and don't jinx ourselves, we may have a real boy document in a few weeks. I have no idea if it's a few weeks or what, but I'm pretty sure it just involves poking the right people in the right order and nothing else. And
never underestimate the bureaucracy of standards organizations.
Yeah.
Even I*TF.
Yeah. So we got feedback back from Ian Goldberg, who was a co-author on the original Frost, and which was minimal, and so that was incorporated into version 12. That's the big one. Yeah, wish us luck.
Good luck.
Awesome. Thank you so much for that. And then I didn't see Nathan on the call today. Does anybody from ECC have any updates regarding research and implementation status?
Nothing in particular. I think our main focus at the moment is the work towards DAGsync, and and obviously keeping Zcashd running. There will probably be more related to that in upcoming calls, but at the moment, no change from last time.
Awesome, thank you so much. See, Deirdre asked.
There was an ask about an update on ZSAs or ZSA zips. Dara, you might be able to help me out here. We are the zip editors, so we've been reviewing
if I can remember.
Yeah, we've been reviewing the Zcash shielded asset draft zips for issuance and transfer and burn. That is ongoing. They are pretty getting updated with implementation changes, and the authors, the ZSA folks, have been responsive. But we are trying to get a synchronous call, at least from the zip editors and the ZSA folks, so that we can avoid some of the latency of these back and forth cycles, about specifics about things that are getting implemented in sort of a forwards looking way for the Zcash protocols in general, but also just how to structure these documents in a way that we generally do for zips and documenting specifications in the Zcash world.
There's also some work that needs to be done on the sort of implementation side, making sure that the circuit fits within 2 to the 11 rows, things like that.
Okay, awesome. And yeah, sorry. Any other questions, comments regarding the content just addressed here? Anyone on the speaking side? Okay, great. We can go ahead and move to open discussion. So I'm going to go ahead and stop my screen share, and we can move into any open discussion items that anyone with speaking permissions might have here, or anyone from obviously the audience as well. So leave it open for a couple minutes here, see if anyone has anything.
Yeah, are people who are not panelists actually able to speak in the chat? Because before I was promoted to panelist, I couldn't access the chat.
It should be the case, because I've seen chats come in before from the last Arborist call, and I didn't edit anything to this Zoom link specifically different. I think Auto Tunafish here in the chat, if you can write a message, if you could, that'd be great. If not, then that would confirm that we can't see any messages there. So I'll give that a couple seconds. If you're, or anyone else who's attending that's not a panelist, if you can write something in the chat. I'll give that like 10 seconds, and then that will probably confirm if not.
Everyone can use the Q&A, even if they can't use the chat. So the chat being open is a call setting, and it doesn't seem to be set on this call. Okay.
All right, well, I will dive in. Okay, chat does not work. Haku just messaged that in Q&A. Awesome, thanks. Okay, and $0, cool. All right, so I'll go into the Zoom and into the two Zoom links afterwards and go ahead and have a look at that and make sure that's fixed. Sorry about that.
If anyone can use the Q&A for questions, that'd be good.
Yeah, thank you.
Adi?
Yeah, so just revisiting the chat we had about the unclaimed ZEC, one of the things that keeps coming up in Bitcoin world is there'll never be exactly 21 million Bitcoins mined. There'll always be a small reminder of Satoshis. So is the same issue with Zcash or?
No. And there's a good reason for that. So the small reminder that people refer to for Bitcoin is the fact that the Genesis block could have claimed 50 Bitcoin but didn't. That is not the case in Zcash because of the slow start. So it was indeed the case that it was impossible to put, like, at the point we forked, it was impossible to put outputs into, like non-zero outputs into the Genesis block because of the way the Genesis block is loaded and so on and so forth. But I picked the slow start parameters so that the intended amount of block subsidy on the Genesis block was 0. So it just works out. So there is still the other thing that people refer to in terms of never hitting 21 million is rounding errors at the bottom when things get small enough, just to the way the halving works. But again, that is just a, if you leave the rules exactly as they are thing, then that's the case. And if one were to, you know, if the community were to go towards some sort of like posterity fund style system, then essentially that delta between like what's actually on the network and what's the theoretical supply says it should be, you know, that lets you get the, you know, those bits become that get, you know, it lets that then become part of the general equation. And then as far as like, if essentially the problem then would be the same problem you have with the rounding error, which is like, what do you do when the, you know, posterity, imagine that we did get all 21 million in and then people are putting funds back in. It was like, well, it's another pool at that point. And it's just, how do you deal with the rounding error of that amount?
I mean, to me, there's an open question whether a cryptocurrency, a Bitcoin-style cryptocurrency whose block rewards go to 0 is sustainable and secure in the long term. And I'm sure that Monero people would say it isn't because they have a tail emission precisely.
Ethereum as well. They are also an inflationary currency. Or like they have a tail mission of that sort. So I
mean, I agree with them. I think that tail emission is necessary, to be honest. So there may be some point at which we change the consensus rules to take that into account. And it's just a matter of how much and when.
That would be something that would require, you know, obviously discussions with the wider community. In, you know, everything that we've discussed thus far in terms of the things tracking and the leftovers and things, that's all just within the existing emissions curve.
Yeah, I want to emphasize that's just my opinion, and obviously it's something that needs to be discussed among the community.
Thank you.
Also, the security requirements for proof of stake may be different than proof of work.
Okay, great. There was a question here in the Q&A that was answered by Chris. Thank you so much, from Zero Dart. So Zcashd 540 soon. And Chris responded, yes, we're hoping for an early release next week, provided that testing goes well. So thanks for the question, Zero Dart, and thanks for the answer there, Chris. Anything else before we wrap this call up and for the evening? Okay, great. Well, thank you so much, everybody. And again, sorry for the last ditch issues with the Zoom link, the Zoom calls. We'll sort out the chat so we have that updated. And if you run into any issues, I'll obviously send an update out via the forums and the Zcashd R&D Discord within the Arborist call section of that channel. And yeah, thank you everyone so much, and hope everyone has a great evening and great rest of the Thursday and going into the weekend.